They told us 3I divided by Atlas was just another visitor from the deep, a faint speck racing through the dark, nothing more than an interstellar traveler. But now, the James Webb Space Telescope has revealed something no one expected. This object is far bigger and far stranger than we ever imagined. Subscribe, because tonight we're peeling back a mystery that space itself has been hiding. Imagine looking up at the night sky. To the naked eye, it feels calm, endless, safe. But out there, in the vastness beyond our solar system, something is moving. Not a planet, not a star, but a traveler from another system entirely. Astronomers call it 3I divided by Atlas, only the third confirmed interstellar object ever discovered passing through our solar system. The first was Oumuamua, the mysterious cigar-shaped object that baffled scientists back in 2017. Then came Borisov, a more familiar comet, but still from far away. And now, Atlas. At first, it was faint, barely visible, a visitor from beyond, likely to swing past and disappear again into the dark. But when the James Webb Telescope turned its golden eye toward it, something changed. The readings didn't match the early predictions. Atlas wasn't small. It wasn't fragile. It wasn't just a faint blur of ice and dust. It was huge. Much larger than astronomers thought possible for an interstellar traveler. And in that size, hidden in the shadows of its form, lies a puzzle no one yet knows how to solve. Tonight, I want you to lean back, close your eyes if you like, and let me take you on a journey, a story that begins with a telescope, the most powerful humanity has ever built, staring deep into the void, only to reveal a traveler much more daunting than anyone imagined. So, what is 3I divided by Atlas? How did it come here? And why does its size matter so much? Let's start at the beginning. Back in 2019, the Atlas Survey System, a sky-scanning project designed to spot asteroids and comets that could threaten Earth, picked up a faint blur. At first, astronomers thought it was a normal comet from our solar system, making one of its routine icy journeys around the Sunday. But the more they tracked it, the stranger it became. Its speed, its orbit, none of it fit the mold. Instead of circling the sun like a comet should, it was cutting across our system. Its path traced back not to the icy Kuiper belt, not even the distant Oort cloud, but somewhere beyond, far, far beyond. Another star, another place, that was the first clue. But the real shock came when Webb looked with its infrared eyes, able to pierce dust and distance like no telescope before it. Webb measured the heat and the reflected light from Atlas. And suddenly, the object astronomers thought was small, maybe a kilometer or two wide, turned out to be enormous, somewhere between 10 and 15 kilometers across. Bigger than Mount Everest, comparable in size to some of the largest comets we've ever seen, and yet this one wasn't from here. It was alien. Imagine that, a mountain-sized object racing through space at tens of kilometers per second, cutting across our neighborhood, and it's not even one of ours. It's a foreign visitor from another sun, another system. What does that mean? Well, the size alone changes everything. A small comet could pass unnoticed, burn away, fade into the dark. But something this massive carries with it the possibility of more gravity, more complexity, more secrets hidden beneath its icy crust. And if Webb's data is right, then Atlas may not be just a frozen wanderer. It may be something else entirely. As scientists scrambled to analyze the data, one thing became clear. The James Webb had opened a new chapter in the story of interstellar visitors. This wasn't just a pebble tossed across the galactic ocean. It was a boulder, a giant. And if objects this big can move between stars, then what else might be traveling in the dark? So tonight, let's explore it. From the first faint detection to Webb's shocking confirmation. From what we thought we knew about interstellar travelers to what Atlas forces us to rethink. Because once you see how big this really is, you can't help but wonder what else is out there waiting to be found. Before we dive deeper into Atlas, let's pause for a moment and think about how rare this really island interstellar visitors aren't something we see every day. In fact, until very recently, we had never seen one at all. For centuries, humans looked up at the stars, charted comets, tracked asteroids, and thought of our solar system as a mostly closed bubble. Things looped around the Sunday they belonged to us. But then came 2017. Astronomers in Hawaii spotted something streaking across the sky. At first, they thought it was just another asteroid, a boring rock. But the more they watched, the stranger it became. It was moving too fast. Its path wasn't an orbit, but a straight cut through our solar system. And its shape, long and thin, like a cosmic cigar, tumbling end over end. They called it Oumuamua. In Hawaiian, it means scout or messenger from afar. And for many people, it truly felt like a messenger. Because it was the first confirmed interstellar object humanity had ever seen. A rock not born here, but thrown into our system from somewhere else. And yet, it refused to fit neatly into any box. Some scientists called it a comet, though it left no tail. Some said asteroid, though its speed and acceleration were puzzling. And then came the wild idea. Maybe, just maybe, it wasn't natural at all. Avi Loeb, a Harvard astronomer, made headlines suggesting that Oumuamua could have been some kind of probe, a thin piece of alien technology sailing through space. That was our first taste of just how weird interstellar visitors could be. Then, only 2 years later, in 2019, another one arrived. This one was more familiar, a glowing, gassy comet, leaving a faint tail in its wake. Discovered by an amateur astronomer named Gennady Borisov, it was quickly confirmed to be interstellar too. Scientists named it after him, Comet Borisov. Unlike Oumuamua, Borisov looked and behaved like a normal comet. Only difference was, it wasn't ours. It had come from somewhere else. And now Atlas. The third visitor. Only the third we've ever seen in human history. And already it's rewriting what we thought we knew because, unlike the first two, Atlas is massive. Oumuamua was small, maybe just a few 100 meters long. Borisov was bigger, but still only a few kilometers wide. Atlas, according to Webb's data, could be up to 15 kilometers across. Think about that for a second. If Oumuamua was like a car, Atlas is like a mountain. And here's where things start to get interesting. Size isn't just a number in astronomy. It changes everything. A small rock drifts. A mountain-sized object carries gravity. Its mass pulls and shapes the space around it. Its surface could hide cracks, cliffs, deep valleys, even frozen oceans. And its sheer size makes one thing clear. Objects like Atlas aren't accidents, they're survivors. To become interstellar, to escape the pull of a home star, an object needs incredible energy. Usually, that happens during the violent early days of a solar system, when planets are still forming and giant gravitational slingshots fling debris into the void. Smaller fragments might crumble or burn away over time, but something as massive as Atlas, it survives. It keeps going. It crosses the gulfs between stars, drifting for millions, maybe billions of years, until chance brings it near us. And that's where the James Webb Telescope comes in. Think of Webb like the universe's biggest magnifying glass. With its gold-plated mirrors and infrared eyes, it sees not just what an object looks like, but what it's made of. Heat signatures, ice, dust, even traces of the chemicals locked inside. When Webb looked at Atlas, the brightness and thermal data simply didn't match a small comet. The signal was too strong, too spread out. The only explanation, it was much bigger than we thought. And that left astronomers with a huge question. If this is only the third interstellar object we've ever spotted, and it's already this massive, how many more are out there? How many have we missed? And if they're big enough, what secrets might they carry? Because here's the thing. Interstellar objects aren't just space junk. They're time capsules. They're pieces of other worlds, other suns, other systems. Imagine holding a rock in your hand that came not from Earth, not from Mars, not even from our sun's backyard, but from a star light years away. It would be like holding a message in a bottle, tossed across the galaxy. That's what Atlas Island, a messenger. And now that Webb has shown us just how big it really is, the message feels louder, clearer, more urgent. But here's the twist. Its size may also make it more dangerous. Because if objects like Atlas drift into our solar system more often than we thought, then Earth isn't as isolated as we once believed. We're part of a much bigger traffic pattern in the galaxy, and sometimes the travelers are enormous. So what does that mean for us? What challenges does a giant interstellar object pose? And why does Webb's discovery spark both excitement and fear? That's where we're heading next. So here we are, a massive interstellar visitor, larger than anything we've seen before, drifting silently across the dark. On the surface, it sounds incredible, a rare chance to study a true traveler from another system. But hidden beneath that wonder, there's a problem. And it's a big one. Because Atlas, as beautiful as it is, raises a terrifying question. What if we're not ready for something this size? Let's start with detection. Astronomers spend billions of dollars building telescopes, running sky surveys, scanning the heavens every night. And yet, this giant slipped through until just now. Why? Because our tools, as advanced as they are, can only see so much. Space is vast. the night sky is endless. Even something the size of a mountain can remain invisible until the light hits it just right. That means Atlas isn't just an object, it's a reminder of how blind we still are. If this colossal traveler can pass so close to us without being noticed for so long, what else is out there? Just beyond our reach. And then comes the second problem, its path. Atlas isn't bound to the Sunday. It isn't looping gracefully like our planets. It's cutting across our system, slicing through like a blade. That makes predicting its motion harder, because it hasn't grown up in our sun's grip. It's not one of ours. Its orbit is alien. When Webb revealed its true size, that calculation suddenly changed. A small object passing through? Fascinating, but not threatening. A giant 15 kilometers across? That changes everything, because a body that big carries consequences. Let's put it in perspective. The asteroid that ended the age of the dinosaurs was around 10 kilometers wide. Atlas could be even larger. Now imagine something of that scale, but not a local asteroid we've been tracking for decades. Instead, a stranger from another star, with a path we barely understand. That's why scientists are uneasy. Not because Atlas is on a collision course, it isn't, but because it shows us what's possible. It shows us the reality of interstellar objects. They're not just small, harmless pebbles wandering in from the dark. They can be mountains, worlds, maybe even more. And here's another wrinkle: composition. Most comets and asteroids we know are predictable. They're made of rock, ice, dust. But Atlas isn't from here. Its chemistry could be completely different. The gases it releases, the structure of its core, even the way its surface reflects light, all of it could surprise us. Some scientists believe that interstellar visitors might even carry the raw ingredients of life, locked in frozen water and complex molecules. If true, Atlas isn't just dangerous, it could be a messenger of life itself, a carrier of alien material drifting between suns. But there's a darker possibility too. What if, somewhere out there, other systems are constantly ejecting objects like Atlas, and we're only now beginning to see them? What if the galaxy is filled with debris on this scale, and Earth is just sitting in the crossfire, vulnerable? That's the real fear Webb's discovery unlocks. Not that Atlas itself will hit us, but that it reveals just how fragile our place in the cosmos really island. Because in the endless night of the universe, giants like Atlas aren't rare miracles. They're warnings. And if this one came, what's next? After Webb confirmed Atlas's true size, something remarkable happened. Almost overnight, observatories all across the world, from Hawaii to Chile, from Europe to the frozen plains of Antarctica, turned their gaze to the same object. It was as if the whole planet suddenly leaned in closer, whispering, "What are you?" Because here's the truth. Every interstellar object is a gift, a messenger. It carries with it the chemistry of another star, another system, another world we may never see. And Atlas, with its massive size, offers more information than anything we've ever studied before. So, how do scientists try to unlock its secrets? They start with light. When sunlight or starlight bounces off an object, it carries fingerprints, tiny clues hidden in the wavelengths. By splitting that light apart, scientists can see whether Atlas's surface is rocky, metallic, icy, or something else entirely. It's like looking at a barcode from billions of miles away. And Webb? Webb is built for this kind of work. Its powerful infrared eyes can pierce through dust, through shadow, and pick up subtle signals other telescopes miss. That means for the first time, we're not just looking at a blurry dot, we're peeling back its layers. Already, there are hints of strange behavior. Atlas isn't reflecting light like our local comets. Its surface seems darker, almost coal-like, but with patches of brightness that flare unpredictably. Some scientists think this could mean it's covered in materials we don't often see, exotic compounds forged in alien systems, scattered across its skin. And then there's the gas. Most comets, when they approach the sun, begin to shed water vapor, dust, and simple molecules like carbon dioxide. But Atlas, it appears to be venting something unusual. Webb has picked up spectral lines, faint signals in the light that don't quite match anything familiar. Could it be ammonia, methane, or something stranger? Nobody knows yet. And that's the beauty of it. Every observation brings us closer, but also deeper into mystery. Think about it. For the first time in human history, we may be holding a direct sample of alien chemistry, not from Mars, not from a passing asteroid in our own system, but from a world that formed under a different star, in a completely different cradle of creation. And if Atlas is carrying those ingredients, what else might it be hiding? Some researchers have whispered about the possibility of complex organic molecules, the building blocks of life frozen deep in its interior. If that turns out to be true, then Atlas isn't just a giant rock drifting through the void. It's a carrier, a courier of cosmic seeds, drifting across the galaxy for eons, waiting to crash into worlds like ours and spark something new. This is why Webb's discovery matters so much. It's not just about size, it's about meaning. Atlas is bigger, yes, but also richer, stranger, and more important than we ever imagined. And as the data pours in, one thing is clear. Atlas is unlike anything we've ever seen before. But there's a catch. The more we learn, the more questions rise. And one question looms above the rest. Where exactly did Atlas come from? Every traveler has a story, and Atlas is a traveler like no other. Imagine this. Billions of years ago, somewhere far away from our sun, a star system formed. It might have looked a little like ours, swirling clouds of dust collapsing into planets, moons, comets, and asteroids. Or maybe it looked nothing like anything we've ever seen, with stars locked in a dance, with giant planets bigger than Jupiter, and with frozen worlds circling in endless darkness. Now, in that distant system, something happened. Something powerful enough to fling Atlas away. It could have been a gravitational tug, maybe a giant planet pulled too hard on a comet, wandering near its orbit and slingshotted it out into interstellar space. Or maybe two stars brushed close together, their gravity tearing through each other's planetary fields, sending debris flying. Whatever the cause, Atlas was launched, and once it left its home, there was no going back. From that moment, It became a drifter, an eternal wanderer, sailing through the galaxy without a destination. No sun to warm it, no planet to orbit, just the endless dark. Now, here's the part that gives scientists goosebumps. We can actually trace Atlas's path, not with perfect accuracy, but with enough clues to sketch its journey, its speed, its angle, the way it entered our solar system. And when astronomers crunch those numbers, they see something shocking. Atlas didn't just wander casually into our neighborhood. No, it's moving at a velocity that suggests it came from very far away. Maybe the outer edges of our galaxy. Maybe even from a cluster of stars we've only glimpsed with telescopes. Think about that. This isn't just a comet from a nearby star. This could be a messenger from a system we'll never visit, a fragment of a place we can only imagine. But there's another layer. Its size changes the story. A small object, like Oumuamua, could have been tossed out easily. But something as big as Atlas? That's harder to explain. It means the forces that ejected it must have been enormous. Perhaps a collision with another massive body. Perhaps the death throes of a star exploding in a supernova, flinging everything around it into chaos. Can you picture that? Somewhere, long ago, a star may have died its explosion, scattering planets, moons, and comets like leaves in the wind. Atlas could be one of those leaves, blown across light years, until it finally drifted into our sky. And here it is now, after billions of years, after distances our minds can barely grasp. Atlas has entered the glow of our Sunday. And for the briefest moment in history, humanity gets to see it. It's almost poetic. We are here tiny creatures on a pale blue dot, watching the arrival of a traveler that began its journey before Earth even existed as it does today. And scientists can't help but wonder, what if Atlas isn't alone? What if there are thousands, millions of these interstellar messengers drifting through the dark, carrying with them the secrets of alien worlds? Maybe we've only just caught a glimpse of the first few, like spotting raindrops before a storm. But here's the problem. For all the excitement, there's a shadow of unease. Because if Atlas is this big, this massive, and it came from so far away, what else could be out there? What if one of these giants wasn't just passing through, but on a direct collision course with us? For now, Atlas poses no threat. It's simply passing by. But its existence forces us to face something uncomfortable. Our solar system isn't sealed. It isn't protected. It's open to the galaxy, open to whatever might drift in next. And if Atlas is proof of anything, it's that we're not alone in this cosmic sea. Picture Atlas now. It's moving silently, effortlessly, like a dark ship drifting through an endless ocean. No sound, no resistance, just the pull of gravity guiding its course. As it entered our solar system, astronomers quickly pulled out their models. They wanted to know, where is it going? What path will it take? Will it swing close to the sun? Will it pass by Earth? Will it escape forever? Or will gravity capture it, making it a new resident of our system? To answer that, they use something called orbital mechanics. Think of it like drawing curves with invisible strings. Every planet tugs at Atlas. Every star and every bit of gravity shapes its path, and the James Webb Space Telescope, with its incredible eyes, gives scientists data sharp enough to feed into those models. The early results? Atlas's trajectory is wide, sweeping, and incredibly fast. It came in from the outer darkness at a steep angle, cutting through our solar system like a needle-piercing fabric. For a while, it'll swing close enough to feel the warmth of the Sunday. Then, unless something unusual happens, it will head back out, fading into the distance once more. But here's the fascinating part. Objects like Atlas don't just move, they interact. Think of Jupiter, the giant of our solar system. Its gravity is so strong that it acts like a cosmic bouncer, redirecting comets and asteroids all the time. Some are captured, trapped in looping orbits. Others are flung out, never to return. If Atlas drifts even slightly closer to Jupiter's pull, its story could change completely. Imagine Atlas being pulled in, not escaping. Imagine it becoming a permanent, though distant, member of our solar system, circling endlessly, waiting for future generations of humans to study up close. That thought alone excites astronomers. A piece of another star system, trapped here, like a relic in a museum. But the other possibility is equally chilling. What if Atlas's path is shifted not into capture, but into danger? Even a small nudge from Jupiter or Saturn, or even Earth itself, could alter its future. A tiny shift in its orbit could change where it crosses the solar system. That's the thing about objects moving this fast. Small differences now can mean huge differences later. That's why scientists track every detail down to the tiniest measurement. Because Atlas may not pose a threat today or tomorrow, but what about in 100 years? 1,000? 10,000? Space works on long timelines. What looks harmless now might not be harmless forever. And here's another wrinkle. As Atlas swings past the sun, its frozen ices will heat up. Jets of gas could burst from its surface, like steam shooting from cracks. These jets act like rocket engines, small, but enough to push Atlas slightly off course. This is called outgassing, and it makes predicting comet paths even harder. So, scientists watch closely every flare, every change, every shift in its brightness. They're not just observing, they're listening for clues about what Atlas might do next. And in a way, it's like trying to predict the behavior of a stranger you've only just met. You know the basics. You know where they came from. You know where they're going for now. But the future, that's harder. And Atlas is no ordinary stranger. It's older than us, older than Earth, older than the sun itself. And its future may hold surprises we can't yet see. For now, the path is clear. Atlas is moving, gliding, whispering through the solar system. But its true destination may still be unknown. To really understand Atlas, you have to imagine the scene from Earth. Across deserts, mountaintops, and observatories perched above the clouds, astronomers point their telescopes skyward, watching. Each night, as Atlas drifts across the stars, those silent machines gather light, turning faint streaks into data. The Hubble Space Telescope, orbiting far above Earth, has already joined the effort. With its clear, sharp eyes, it catches the glow of sunlight reflecting off Atlas's icy surface. Hubble has been humanity's workhorse for decades. It's like a trusted elder, steady and reliable. The images it sends back give us detail, structure, the way Atlas's brightness changes night after night. But then there's James Webb, the new giant. The telescope, with a mirror so large it can catch whispers of light that have traveled for billions of years. Where Hubble sees invisible light, Webb peers into the infrared, the wavelengths of heat. To Webb, Atlas isn't just a streak of light. It's a living object. Its frozen core glows faintly. Its gases radiate in unique patterns. It reveals fingerprints, the chemistry written in starlight. Think about that. From nearly 1 million miles away, James Webb can tell what Atlas is made of. Carbon compounds, frozen water, ammonia, maybe even organic molecules, the same building blocks that could spark life. It's like reading a message written billions of years ago, preserved in ice, now unlocked by our technology. But Webb and Hubble aren't alone. On Earth, telescopes from Hawaii to Chile track Atlas too. Each location has its strengths. The giant mirror of the Very Large Telescope in Chile, the radio antennas of ALMA, the massive Pan-STARRS survey cameras in Hawaii, they all contribute. Like members of a symphony, each one plays a note, and together they build the music of discovery. And here's the beautiful part. Every instrument sees Atlas differently. Hubble sees the light it reflects. Webb sees the heat it gives off. Radio telescopes sense the particles and magnetic fields surrounding it. Ground-based telescopes measure how its brightness flickers, hinting at rotation or bursts of gas. Piece by piece, Atlas becomes less of a mystery and more of a story we can read. But it's not easy. Atlas is faint. It's moving quickly across the sky. To track it, telescopes must move too, following its arc, adjusting their gaze in real time. Imagine trying to photograph a bird flying past the full moon, except that bird is hundreds of millions of miles away. That's the scale of the challenge. And then comes the real work, making sense of the light. Each photon that hits a detector carries information. Scientists break it apart with spectrographs, spreading the light into rainbows. Each color, each dip and spike is a clue. Oxygen leaves a signature, carbon leaves another, water vapor sings in yet another. It's like solving a puzzle made of colors, invisible to the human eye. Late at night, in control rooms lit by glowing screens, researchers lean forward, eyes fixed on the data. They aren't just watching a rock pass by, they're reaching across space, across time, touching something alien, something ancient. Some of them imagine Atlas as a messenger, a traveler carrying secrets from its birthplace. Others see it as a relic, a frozen sample of another star system preserved for billions of years. Whatever their perspective, they all share the same thought. This is rare. Objects like Atlas don't come often, and when they do, we must pay attention. Because once it's gone, it may never return. When the first spectrographs broke down the light from Atlas, what they revealed was more than just pretty lines and graphs. It was a recipe. Inside that faint light were fingerprints, little dips, where certain wavelengths were missing. Each dip meant that something inside Atlas had absorbed that light. And from those tiny gaps, astronomers could tell what was hiding there. Water, frozen into rock-hard ice, buried in the nucleus, carbon monoxide, seeping out in faint gas streams, methane, a fragile molecule that breaks down easily yet somehow survived in Atlas's frozen vault for billions of years. And then, more complex compounds organics. The same kinds of carbon chains that form the backbone of amino acids, the ingredients life needs to spark. To the naked eye, Atlas is just a cold traveler. But through Webb's mirror, it becomes something else. A cosmic pantry stocked with the very stuff that makes planets, oceans, and maybe even biology possible. Think of it like this. Every comet, every interstellar wanderer like Atlas is a time capsule. They carry the raw ingredients of creation. When Earth was young, billions of years ago, swarms of objects like Atlas crashed into its surface. With each impact, they may have delivered drops of water, bits of carbon, seeds of chemistry that later bloomed into life. Without them, maybe Earth would have stayed dry and lifeless. So studying Atlas isn't just about knowing how big it island. It's about asking, could life anywhere in the universe depend on visitors like this? Could other worlds around distant stars be seeded by comets from afar? Astronomers sometimes call these objects messengers of the dawn, not because they bring prophecies, but because they remind us of beginnings. The beginning of Earth, the beginning of chemistry, the beginning of us. And Atlas carries another secret in its chemistry: ratios. You see, not all water is the same. Some molecules carry heavy hydrogen, called deuterium. By comparing the ratio of normal hydrogen to heavy hydrogen, scientists can tell where that water came from. Some comets match Earth's oceans perfectly, others do not. It's like finding the accent in someone's voice, a clue to their homeland. If Atlas's water matches Earth's oceans, it adds to the idea that comets build our seas. If it doesn't, then maybe Earth's water came from a different source, entirely asteroids, or even deep within the planet itself. Either answer rewrites our story, and here's the stunning thing. Atlas doesn't belong to our solar system. It was born elsewhere, which means its water, its carbon, its organics, they're alien. Not alien as in little green men, but alien as in foreign, ancient, untouched by the Sunday. If those building blocks can be found in another star system, then life's recipe might not be unique to us. It might be universal. Close your eyes for a moment and imagine this: a young planet orbiting another star. For billions of years, it sits empty, barren, dry. Then, just like Earth, a wave of comets arrives, carrying ice and organics. The ground soaks up water, molecules swirl in tidal pools, and maybe, just maybe, chemistry stirs and life takes its first breath. Atlas, drifting silently past our sun, reminds us that what happened here could happen anywhere. But of course, chemistry only tells part of the story. To really understand Atlas, we have to look deeper, not just at what it's made of, but at where it came from and where it's going. because its path across the galaxy might be just as important as the ingredients it carries. Atlas is not like the comets we usually know. Most comets loop around the sun in long, stretched ellipses. They're part of our solar system, born in the distant Oort cloud or Kuiper belt, drifting in dark orbits until gravity pulls them inward. But Atlas is different. Its orbit doesn't loop back. It isn't bound to the Sunday. Instead, its path is hyperbolic, open-ended. That means it came from far beyond our solar system, and once it leaves, it will never return. Atlas is an interstellar visitor. That word alone changes everything. It means this icy traveler was born around another star in another system entirely. For billions of years, it may have circled its own sun, perhaps in a cloud of icy fragments, just like our Oort cloud. Then something happened, a gravitational nudge, maybe from a giant planet or even a passing star. That gentle tug sent Atlas drifting away from its birthplace, cast into the interstellar dark. Think of it. Atlas has been traveling for eons, hundreds of millions of years in the void between stars, alone. No warmth, no light, just silence and starlight. And then, by sheer chance, its path brought it here into our neighborhood, into our sun's gravity well, into the gaze of human telescopes. We've seen only a handful of such interstellar visitors before. The first was Oumuamua, discovered in 2017, a mysterious cigar-shaped object that sped past us without warning, sparking endless debates about what it was. Then came Borisov, a comet-like traveler in 2019. And now, Atlas joins them, another messenger from beyond. But Atlas is different from them too. Oumuamua was dry, rocky, and strange. Borisov looked more like a normal comet, shedding gas and dust. Atlas, however, is larger than Oumuamua, more active than Borisov, and perhaps older than both. It may carry the richest story of all. Where did it come from? Astronomers trace its orbit backward and find that it may have drifted near stars in the constellation Lyra millions of years ago. Before that? Who knows? Its birthplace is lost in time. But what matters is this. Atlas has traveled further than anything we can imagine, and it is carrying its story across the stars. Imagine it. Atlas may have once circled a star not so different from our Sunday. Around that star, planets may have formed. Maybe oceans existed there, maybe even life. Atlas might have been part of that system's own version of an Oort cloud, a frozen archive of its history. And now it passes through ours, silently sharing its tale, if only we know how to read it. Astronomers look at Atlas and see not just a comet, but a messenger of possibility. If interstellar objects like this are common, then perhaps systems all across the galaxy exchange them like seeds in the wind. Seeds that carry water. Seeds that carry organics. Seeds that carry the potential for life. Atlas is not just an alien comet. It is a reminder that the galaxy is not empty. It is alive with exchange, with motion, with the quiet sharing of cosmic ingredients. And here's the eerie part. If Atlas came to us, how many more have passed unnoticed? How many interstellar travelers slipped through our skies long before telescopes existed, their secrets lost to the night. Atlas is the one we caught, the one we can study, the one that forces us to ask, how many of these icy messengers are out there, drifting between the stars, carrying the story of countless worlds we will never see. Now that we've traced Atlas's mysterious past, it's time to ask, where is it going? What happens to this giant interstellar traveler once it finishes its brief encounter with our solar system? Astronomers ran the numbers. They mapped its hyperbolic trajectory, that open-ended path that means it's not staying. The result? Atlas is headed back out into the dark, destined to wander the galaxy once again. It will pass beyond the reach of our planets, beyond the Oort cloud, and drift back into the interstellar void. In a sense, Atlas is like a guest at a cosmic station. It stopped here, let us take a look, and then moved on without a word. And just like that, it will vanish into the deep black, becoming nothing more than a faint dot, then nothing at all. Think about that for a moment. We live in a time when our telescopes are powerful enough to catch it, to track it, and even to learn about it. If Atlas had passed by just a century earlier, no one on Earth would have even known it existed. And here's the haunting part. Once Atlas leaves, no human eye will ever see it again. Not in 1,000 years, not in 1,000,000. It will fade into the silence of deep space, its secrets locked within, carrying them forever beyond our reach. But while it's here, Atlas gives us a rare opportunity. By studying its orbit, we can learn about the forces that shaped it. By examining its chemical makeup, we can compare it with objects born in our own solar system. And by imagining its future journey, we glimpse the endless highway of interstellar travelers that must exist out there, each carrying pieces of their home systems. Astronomers have a beautiful way of looking at this. They say that objects like Atlas are like postcards from another star, a tiny frozen snapshot carrying clues about a place we'll never see, from a time we'll never know. As Atlas drifts away, it might eventually cross paths with another star system. Not in our lifetimes, not in 1,000 lifetimes, but eventually its path will intersect with some distant someday. And just as it once circled its original star, perhaps it will be captured again, pulled into a new system, a wanderer finally finding a home. Or maybe Atlas will wander forever, a ghost of ice and dust carried endlessly between stars, never settling, always traveling. That thought alone is humbling, that something so massive and so old can spend eternity drifting, never resting, never belonging. And yet, here's the twist. In a way, Atlas already belongs everywhere. Its journey ties together star systems across the galaxy. It connects worlds. It carries materials, water, carbon, organics that are universal building blocks of life. Whether it knows it or not, Atlas is part of a galactic network of sharing, a reminder that nothing in space is truly alone. When astronomers talk about the future of Atlas, they often speak less about its path and more about its meaning. Because the real story isn't where it's going, it's what it represents. If Atlas is proof that interstellar visitors are more common than we thought, then that means our galaxy is constantly mixing, constantly exchanging. It means that what forms on one world doesn't stay there. It drifts, it spreads, it travels. That idea leads to a profound possibility. Maybe life itself, or at least the ingredients of life, travel this way, from star to star, from system to system, spread not by intention, but by nature. And so, when we watch Atlas leave, what we're really watching is a bigger story. One about connection, one about sharing, one about the possibility that life, in all its forms, might not be confined to just one world, one star, or even one galaxy. Atlas is on its way out, but its story is only beginning for us. If Atlas carries dust, ice, and carbon, could it also carry something even more precious? The ingredients of life itself? This brings us to one of the most captivating ideas in science, Panspermia. It sounds like something out of science fiction, but it's a theory scientists take very seriously. The word means seeds everywhere, and the idea is simple life, or at least the building blocks of life, might spread across the galaxy by traveling on objects like comets, asteroids, or interstellar visitors such as Atlas. Imagine this. Billions of years ago, when the Earth was still young and barren, comets may have delivered the water that now fills our oceans. They may have also carried amino acids, the tiny molecular structures that form proteins, the foundation of every living thing. And if it happened here, why not elsewhere? Every time an object like Atlas enters a new system, it's carrying cargo, dust, water, organic molecules. Some scientists even suggest that hardy forms of microbes, if shielded in rock or ice, could survive the long, cold journey through space. Think about that. Entire worlds may be sharing microscopic passengers, scattering them like seeds across the galactic garden. This makes Atlas more than just a frozen traveler. It makes it a messenger, a courier of potential life. Now, skeptics point out life is fragile. The radiation of deep space, the endless cold, the violent forces of ejection, they all seem like death sentences for anything alive. And yet, over and over again, we've learned that life is tougher than we think. Microbes on Earth have survived boiling acid, crushing depths, and even exposure to outer space for short periods. It's as if life refuses to die. So, when we watch Atlas sail through our system, the question becomes more than scientific. It becomes personal. Could the atoms that build us have come from a comet just like this? Could our very DNA carry the fingerprint of a star system light years away? Astronomers love to remind us that we are made of stardust. Every atom in our bodies was forged in the hearts of ancient stars. But Panspermia takes it one step further. Maybe we are not just stardust. Maybe we are stardust that traveled, carried across the galaxy on a lonely rock or icy visitor until it found a home on Earth. And here's where Atlas becomes more than just a comet. It becomes a mirror, a reflection of our own story. We too are travelers. We too came from the stars. And maybe, just maybe, Atlas carries the same possibility for another world. Someday, when Atlas drifts into another star system, who knows what could happen? It might crash into a young planet, delivering water, carbon, and the seeds of life. And billions of years later, someone might look up at their night sky, wondering where they came from, never knowing that a small icy visitor from another system carried their beginnings. In that sense, Atlas isn't just leaving us, it's continuing the ancient chain of connection. The universe handing out seeds, one world at a time. For every dream of cosmic gardens, there's a shadow. Because if comets like Atlas can deliver life, they can also deliver death. This is the unsettling side of Panspermia. The idea that not all seeds scattered through the stars are good ones. Some may be more like weeds, or worse, poisons. Imagine Atlas drifting across the galaxy not as a courier of hope, but as a carrier of alien microbes, organisms completely unknown to us, locked in ice for millions of years. Here on Earth, even the tiniest virus can change history. So what would happen if a comet brought something our immune systems or our entire biology has never faced before? A microbe, not from our world, not even from our sun's neighborhood, but from a star system far away. It sounds like science fiction, yet scientists have already found hints that space dust contains complex organic chemistry, amino acids, sugars, even nucleobases, the stuff that forms DNA. And if molecules this complex can survive in the void, what about life itself? Picture Atlas as a silent ark, carrying passengers frozen in slumber, waiting for impact. And when it collides with a planet, those passengers wake up. Of course, many argue that the odds are vanishingly small. Radiation in deep space should fry fragile organisms. The icy temperatures should break apart their chemistry. Yet, we've underestimated life before. On Earth, we've found bacteria buried miles beneath the ocean floor, thriving in complete darkness. We've seen microscopic creatures survive being boiled, frozen, and even blasted into space itself, only to come back alive. So, maybe the void isn't a death sentence. Maybe it's just another test that life has already passed. And here's the haunting thought. If Atlas can spread life to other worlds, could it also spread destruction? Imagine an alien world blooming with life completely different from ours. Now imagine a comet like Atlas crashing there, bringing something foreign, something that doesn't belong. That world's ecosystem could collapse. Entire species might vanish before they ever evolve into something greater. The same fear exists here. If a comet delivers something strange to Earth, would we even recognize it? Or would it slip into our oceans, our soil, our air, before anyone knew what was happening? Astronomers don't often speak of this side. It feels too speculative, too unsettling. But the universe has never promised us safety. For all its beauty, it's also a place of unknowns. A place where even the gift of life may come with hidden costs. Atlas, then, is a reminder. Not every messenger is a friend. Not every seed grows into something kind. And yet, as unsettling as this is, it's part of the same cosmic truth. The universe does not choose sides. It simply sends out possibilities, life or death, growth or ruin. The comet doesn't decide. It just carries. So when we look at Atlas and imagine what it might bring to another world, we can't help but feel both awe and fear. awe at the idea of new beginnings, fear at the thought of endings. It's this balance, this razor's edge between wonder and danger, that makes objects like Atlas feel almost alive, like characters in a story far bigger than our own. So what happens next for Atlas? Right now, it's just drifting, a silent wanderer, pulled ever so slightly by the sun's gravity, but still racing away. Unlike the planets, which orbit in steady circles, Atlas is on an open road. Its path is hyperbolic a shape that means it will never come back. Once it passes through our neighborhood, it's gone forever. That thought alone is strange. We are watching something that comes close to us only once in the entire history of our planet. Dinosaurs never saw it. The first humans never saw it. And once it slips away, no one else ever will. Astronomers trace its orbit like detectives. They look at its angle, its speed, the tilt of its path compared to the solar system. And what they found is that Atlas didn't just fall from somewhere nearby. It's interstellar, meaning it came from outside, from far beyond the sun's reach. Its origins are still a mystery. Maybe it was ejected from another star system billions of years ago, when planets were still forming and everything was chaotic. Maybe it's been traveling ever since, crossing the dark spaces between suns like a lone ship with no home port. And its future? Well, Atlas is on track to leave us behind and head back into that dark ocean. In 100,000 years, it may pass near another star. In 1,000,000 years, it may slip through an entirely different solar system, glowing faintly as it drifts past alien worlds. Imagine that, somewhere, long after we are gone, an intelligent species might look up and spot Atlas in their skies. They may point telescopes at it, puzzled by its path. They might even send probes, asking the same questions we ask now. Where did it come from? What does it carry? Why is it here? In this way, Atlas is like a message in a bottle, thrown into the cosmic sea, drifting from one shore to another. Only the sea is endless, and the bottle may never find a shore at all. But here's what's haunting. Even if Atlas never meets another civilization, it still keeps the possibility alive. It's a symbol of connection across time and distance. Proof that material from one star system can travel to another. Proof that the galaxy is not a set of islands, but an ocean with currents and things do cross it. Some astronomers even call objects like Atlas galactic mail carriers. They move too slow to be useful to us. Of course, even at its speed, Atlas would take tens of thousands of years to reach the nearest star. But in cosmic terms, that's not so long. It means the galaxy has been trading material for billions of years, with comets like Atlas acting as the couriers. And if just one of those deliveries carried the right chemistry or something even stranger, then the story of life across the stars changes. Suddenly, we're not just isolated sparks of biology. We're part of a web that stretches from one star to another, with objects like Atlas as the threads. The fate of Atlas, then, is simple and yet profound. It will leave us. It will travel on. It will fade from our skies. But it will also continue its journey, perhaps outliving not only our species, but our planet, our sun, and everything we know. Long after Earth is gone, Atlas will still be moving, silent, patient, carrying with it whatever secrets it holds. And in that way, it is immortal. When astronomers first confirmed Atlas was interstellar, many of them smiled, but many also felt something else. A strange tug, a kind of melancholy. Why? Because when we look at Atlas, drifting endlessly through space, we can't help but see ourselves. Think about it. Humanity is a young species, a few 100,000 years old at most. We've only just stepped out of our caves and into the light of technology, yet already we're restless. We've launched probes like Voyager 1 and Voyager 2, sending them into the dark, just as Atlas came into ours. We've sent out signals, radio waves that stretch across the void, carrying our voice into silence. In a way, Atlas is like looking in a cosmic mirror. It's a wanderer, homeless, drifting, never to return. And aren't we too, in a sense? Earth is our cradle, but it won't last forever. One day, if we want to survive, we'll have to leave. We'll become interstellar travelers ourselves, riding metal ships instead of icy rock. But the feeling will be the same. The connection goes deeper still. Atlas carries within it traces of its home system, chemicals, minerals, maybe even compounds we haven't yet identified. And we too carry the traces of Earth with us. Every astronaut who has ever stepped beyond the atmosphere took with them not just food and air, but the imprint of our planet, our biology, our culture, our stories. If we ever cross into another star system, we'll be carrying Earth inside us, just as Atlas carries its home. But here's the haunting part. Atlas doesn't have a purpose. It's not seeking anything. It's just moving, pushed by forces billions of years old. And yet, when we watch it, we imagine purpose. We imagine it as a messenger, a warning, a sign. That's because humans are wired to tell stories. We look at a drifting rock and project onto it our deepest questions. Where do we come from? Where are we going? Are we alone? It's the same reason Voyager's golden record exists. Carl Sagan and his team placed music, greetings, and images on a metal disc and strapped it to a probe that would almost certainly never be found. Why? Because we couldn't resist. We had to tell our story. We had to imagine someone, somewhere, someday might listen. Atlas is the natural counterpart to that. It's someone else's golden record, though in this case, the record may be blank, or so damaged by time that no one can ever read it. But its mere existence proves that cosmic drift is real, that things travel, that worlds touch worlds. And if Atlas mirrors us, what do we see when we stare into it? We see loneliness. We see curiosity. We see the need to move, to search, to cross boundaries. We see fragility too, because Atlas, for all its vast size compared to us, is still just dust against the infinite backdrop of the galaxy. Astronomers joke sometimes calling Atlas the homeless comet. But maybe it's not homeless at all. Maybe home is simply movement. Maybe its home is the galaxy itself. And maybe, just maybe, that's our destiny too. Not to stay rooted on one planet, but to drift, to travel, to spread. The universe has a way of showing us who we are by placing a mirror in the sky. Sometimes that mirror is a telescope lens. Sometimes it's a faint blue dot like Earth seen from Voyager 1. And sometimes it's an icy wanderer like Atlas, reminding us that the story of movement, of exploration, isn't theirs alone. It's ours too. So when we talk about Atlas being bigger than we thought, maybe it's not just the physical size. Maybe it's the meaning. It looms larger in our imagination than in the sky. It's a symbol of distance, of time, of the endless road. And in the quiet hours of the night, when you picture it drifting through the dark, maybe you're really picturing us. So, here we are. After 2 hours of wandering through the cosmos, tracing the faint path of a comet that doesn't even belong to our solar system, we end where we began, staring into the dark, wondering. 3I divided by Atlas began as just a faint signal in a telescope, a blur of ice and dust. But as scientists studied it, they realized it wasn't just a comet. It was a messenger not in the sense of carrying words or intent, but in what it represented. It told us that the galaxy is alive with movement, that things travel, that our solar system is not a locked box, but a crossroads. And maybe that's the quiet lesson hidden in its icy trail. The universe is bigger, stranger, and more connected than we can yet see. The James Webb Space Telescope confirmed Atlas is much larger than anyone expected. But maybe size was never the real surprise. Maybe the real revelation is that something born under another sun could drift all this way and, for just a short moment, pass through our night sky. When you close your eyes tonight, think about that. Think about Atlas, still moving, still drifting, still carving its silent path across the stars. It will never stop. It will never turn back. And in some ways, neither will we. Humanity, like Atlas, is built to move forward into the unknown, into the dark, into the future. And maybe one day, some other civilization, light years away, will look up at their own night sky and see us drifting past just as we saw Atlas. So, as you let sleep take over, let that thought carry you. We are not alone in our drifting. The galaxy is full of wanderers, and every one of them tells a story. If this journey kept you company tonight, don't forget to subscribe so you always have another story waiting for you in the stars. And when the next video pops up on your screen, let it be the next step in your own cosmic voyage.